it's always important to read carefully all the instructions on the front page before starting. Notice that we're told very clearly that all our units need to be written in full. We are not permitted in this exam to abbreviate. You'll see abbreviations of units in your BNF and elsewhere, but for this exam, take care to avoid all abbreviations. We're given 30 minutes for this exam. Students permitted extra time are given a little bit more. And as usual, there are 10 questions on the paper, each receiving 1 mark. And finally, it tells us to write our final answer in the answer box provided. And this is important, including the units. So don't forget the units. If you miss the units out, you lose the point. There's no half points in this exam. Okay, let's dive in. Question 1. We're asked to convert 1.5 milligrams into micrograms. Now this is a conversion of metric units and their weights. So most students like to jot down something looking a little bit like this standard staircase with kilograms at the top, then goes down to grams, then milligrams, and then micrograms. The key thing to remember when learning this and using this is that if you are asked to convert downstairs, you're timesing by 1,000, upstairs you're dividing by 1,000. Now milligrams to micrograms is clearly going downstairs by 1 step, so we'll have to carry out 1.5 times 1,000. Use our calculator for that, and that comes out to be 1,500. Now if you're comfortable doing this pen and paper, whilst I'm not going to forbid you from doing it, I would remind you that as this is an exam and you only have 30 minutes, my advice would be to use the calculator and then think about whether your answer looks right or not afterwards. Okay, we'll put that in our answer box, 1,500, and we don't yet have the marks until we put the units. Well, if I go back to the question, it tells us to convert into micrograms, so I put micrograms into my answer box. And that's question 1 done. On to question 2. It's another conversion question, and it also happens to be another conversion question involving weight. So I'll use the same diagram, my same weight diagram, and now we're being asked to convert micrograms to milligrams. Now microgram is on the bottom step, so we're going up to milligrams, which means divide by 1,000. So my calculation is 625 divided by 1,000. Again, I'll use the calculator, and that comes out to be 0.625. Do not do any rounding unless they tell you to. So find the answer box, pop it in the answer box, and again, what are my units? Well, my units I'm moving to are milligrams, so put them into the answer box. And we're done with that one. Question 3. Very wordy question, but let's unpack it. The doctor prescribes 150 milligrams of an old suspension paracetamol. The bottle contains 120 milligrams in 5 millilitres. How many millilitres will be given? Now this is a standard liquid dose calculation, and many of us have learnt the formula, what you want over what you've got times what it's in. Now whilst it's a useful formula, it tells me I'm going to be multiplying a fraction by a value. Sometimes we are a little bit confused as to what each of those terms mean. Now what you want means what you want to give the patient, and what you've got means what have you got in stock. So I often like to think about patient and stock. In fact, I think of the old adage, the patient comes first. That tells me what value to pull out of the question first. Now I want to give that patient 150 milligrams, so that's going to go on top. My stock strength is 120 milligrams, that goes on the bottom, and that's in 5 millilitres. So I can now write down, using that formula, my calculation. You'll notice that I've also put in that calculation the units, because I need to keep an eye on this fraction part, and I need to ensure that the units are the same. Now they are both the same, they're both milligrams, so I can, as it were, in my mind's eye, cancel them out and proceed. If they were not the same, you'd have to convert one of them to make them the same. You see, in a very real sense, they do cancel out, leaving the unit of my answer to be millilitres. It is a mathematical procedure called dimensional analysis, but I won't go into that here because we simply don't need it. So calculator out, 150 divided by 120 times 5, because it's always top divide bottom to turn a fraction into a number. Now that comes out to be 6.25. So we put the 6.25 into the answer box. What are the units? It says here how many millilitres will be given. So there's our units, millilitres. We knew that from the formula. Once the milligrams were cancelled, we were going to be left with millilitres. And I reflected that in my working out. And that's question 3 done. Question 4. You need to set up an overnight NG feed. The total volume to be given is 0.25 litres over a period of 10 hours. How many millilitres per hour should be given? Well, we'll have to take a couple of steps to work this one out. Step 1 is I'm going to convert that 0.25 litres into millilitres. Now I'm doing that because I know my final answer needs to be millilitres. Now this is a volume question, so rather like the weight question, I have a little sketch that I use, and here instead of a staircase it's more of a step. Same idea, the highest volume goes on top, litres, and as I go downstairs I go down to the units below, millilitres. Going downstairs is times 1,000, going upstairs is divide 1,000. Well, litres to millilitres is going downstairs, so I need to do 0.25 times 1,000. And with my calculator, that tells me I have 250 millilitres. Now that's only step 1. The question told us that we were given this volume over 10 hours. So to work out the mils per hour, I need to divide that 250 millilitres by 10. So step 2 is to divide our volume by the number of hours. 250 divided by 10 is 25. What units will it be? Well, the units aren't just millilitres, but millilitres per hour. So let's put that into the answer box. 25 millilitres per hour. And we're done with that question. Question number 5. A child weighs 12 kilograms is prescribed 7.5 milligrams per kilogram of a drug every 8 hours. How many milligrams of the drug will be given per day? Again, this is a multi-step question. The first thing I'm going to do, my step 1, is multiply this dosage by the child's weight. And I know to do that because we're told it's 7.5 milligram per kilogram. I could have read that as per kilogram body weight. So I will do 7.5 milligrams times 12, and that equals 90 milligrams. You might be wondering where the kilogram has gone in my calculation, but that child's weight in kilogram was simply a multiplier. It's the milligram that I'm timesing by the 12, and it's the milligram that survives into the answer. It does make sense if you think about it. So that value tells us how much the child receives every 8 hours, but we now need to know how many occasions, how many dosages that child will receive in a day. So step 2, to work out how many doses in a day, we'll simply divide a day, 24 hours, by the 8 hours. Well, 24 hours divided by 8 hours is 3. So I know that I will be giving that child 90 milligrams of the drug on 3 occasions during the day. So our final step, step 3, is to multiply those two values together. Well, 90 times 3 gives us 270 milligrams. So again, pop that into the answer box, and the units, milligrams, I can confirm there, write it out fully, milligrams. On to question number 6. The child is prescribed 75 milligrams of a drug to be administered intravenously. The preparation of the drug is 2 milligram per milliliter, that's the stock strength. How many milliliters will be given? Once again, this is a liquid dose question. What you want over what you've got times what it's in. Well, the patient number, the one I want to pull out first, is that 75 milligram. The stock number is 2 milligram, And when it says per millilitres, that means 2 milligrams per 1 millilitre, or 2 milligrams in 1 millilitre. So our calculation becomes 75 milligram divided by 2 milligram times 1 millilitre. Checking my fraction, the units are the same, so no need to act upon that. The calculator, I'll do the step 75 divided 2, top divide bottom, times 1. And that comes out to be 37.5. Pop that into my answer box. What are the units of my answer? Well, it is millilitres, as is confirmed there, and in my calculations as well. So write millilitres into my answer box as well. Question number 7. A child requires 45 milligrams of medicine every 4 hours. How many milligrams will be administered per day? Now you'll notice there's no need to convert because we're given the dosage in milligram and they want the answer in milligram. All we have to work out is how many times will I be giving that child a particular dose. Well, every 4 hours I need to think how many of those occasions, visits, will occur in a day. So how many doses per day? Well, there are 24 hours in a day. If I divide that by 4 hours, I get 6. So there are 6 occasions when I will administer that amount of drug, that 45 milligrams. So my second and final step is to multiply that 6 by the 45. So 6 times 45 is 270. Pop that into my answer box. We know the answer is going to be in milligrams because again we've checked in the question. So it's 270 milligrams. Question number 8. This is the fluid balance question, and we're asked to calculate the patient's fluid balance, indicating the net balance in millilitres and whether your answer is positive or negative. Step 1. Find the total input. Well, the total input is 175 millilitres plus 15 millilitres, and that gives us 190 millilitres. Step 2 is to find the total output. Now here there was only one value given, which is 153 millilitres. The key formula for fluid balance, step 3, is input minus output. So that is simply 190, take away 153, that gives us 37 millilitres. So pop that into my answer box. Now what else do I need to do? We need to give the fluid balance in millilitres, so let's add that to my answer box. But there's a final sting in the tail here. It says indicate whether your answer is positive or negative. Well, this patient is not dehydrated and there wasn't a negative sign when I used the calculator, so that must be a positive number. So I'll write the word positive as was instructed in that first page. Question 9. A 2-year-old child weighing 12 kilograms requires 30 milligram per kilogram daily of ibuprofen. How many milligrams will be administered per day? Now this question looks difficult. It looks like it might even be multi-step, but it simply isn't. We need to give that child 30 milligram per kilogram dose in a day. So all I have to do, it's a single step question, is to multiply that dosage by the child's weight. So I've got 35 milligrams multiplied by the child's weight, and again that child's weight in kilogram is merely a multiplier. I do not worry about the units of kilograms. 35 times 12 is 420. So there's 420. I know my units of my answer is going to be milligrams, so I'll include that as well. On to the final question. An intravenous infusion commences at 14:45 hours and will take 1 hour and a half to complete. At what time, using a 24-hour clock, will the infusion complete? Now they've already given us the start time in 24-hour clock. You'll see it in different formats. Sometimes they have no dots, sometimes they have double dot. This one happens to use single dot. It's not a problem. What is important is that you remember it's 24-hour and not 12-hour, and that you always give 4 digits in a time. So the first thing I'm going to do is I'm going to write down the start time, which was 14:45. And then I have to do some thinking. Depending on the instructions, I have to either add forwards or backwards. Well, I'm adding forwards here because it says it started at 14:45 and takes 1.5 hours to complete. So I must add from that 14:45 1.5 hours. Now sometimes people like to convert it to normal 12-hour clock, but here I'm going to add the 1 hour, so 14:45 becomes 15:45, and then add the half hour. Now half an hour is only 30 minutes, so 15:45 add 30 minutes takes us just to 16:15. You might need to draw little clocks for this, but do not use a calculator, because even though that number used a dot as a convention for 24 hours clock, it is not a true decimal. So be mindful of this particular question. And so all that remains is to put that answer into the answer box. Well, 16:15 isn't the full answer, because look how they wrote it in the question. They called it 14:45 hours. So let's add a label to it so that all our answers have got a context, have got a label. And that's our 10 questions done. Now with practice, you should get pretty efficient with this paper. So hopefully there'll be time at the end to check. So I want to leave you with just a few thoughts about what you would do with that check-in time if you so have it. First thing I would suggest you do is go back to any questions that you weren't happy with or you struggled on. Hopefully you see by the end of the paper you'll feel a little bit more confident, a little bit more relaxed, and perhaps less anxious about the mathematics itself. And you might find a question you struggled on earlier will be a little bit more accessible later on. Also, check for each question you have inserted a unit or a label and that they are the correct units or labels. It is very, very easy to get this wrong, and a small mistake here, a small slip of the pen, and you have lost the mark for the question. And finally, use common sense. You're training nurses, you know what a drug dosage should look like. So if something appears to be unreasonable, there's a very good chance you made a mistake and you might want to recalculate. The lovely thing, of course, about having a calculator for this paper is that you can check every question as you go along with the calculator to make sure that you have pressed the buttons correctly. This is another reason why I would not advocate you doing this purely by pen and paper means. You are looking for efficiency and accuracy just as you would do on a drug round. Okay, thank you very much and good luck in the examination.